Good afternoon, everyone, and welcome to the 9th of the 13 webinars that are part of the 2020 EMOS Webinars program. My name is Gaia Bertarelli. I am postdoc researcher in statistics at the University of Pisa in Italy, and today I will act as the webinar facilitator. As this is a live event, I would like to specify that today I am connected from my house, as all the other members of the EMOS staff of the University of Pisa, as our speaker, and I guess also as many of you. Now, going back to our webinar, let me first explain for any newcomers that EMOS stands for European Master in Official Statistics, a joint project of universities and data producers in the EU member states, EFTA, and EU candidate countries. If your university is interested in applying for the EMOS label, please consider that an open call for university is available on the EMOS dedicated page on the Eurostat website. For staying in contact with the EMOS news and community, please follow the EMOS on Twitter. The EMOS account is @EU_EMOS. Now, before I give the floor to our speakers, let me briefly explain how we run the webinar today. As a participant, you can watch and listen to the session. To interact with the presenter, you can use the chat represented by the comic symbol. We encourage you to prepare your question and pose them during the presentation on the question breaks. We will have some questions break and a final discussion to reply the questions. Should you have any technical problem, please try restarting the Skype for Business or the computer or device you are using. For a more specific technical question, you can use the chat and you will receive a personal reply. In any case, please consider that the slides of the presentation are already available on the EMOS 2020 event website. I also inform you that the webinar will be recorded. Today, I have the great pleasure to host Professor Monica Pratesi and Professor Caterina Giusti from the University of Pisa. Monica Pratesi is a full professor of statistics at the Department of Economic and Management of the University of Pisa, director of the Tuscan University Research Center Camillo da Gum on advanced statistics for the equitable and sustainable development, and member of the board of the European Master in Official Statistics, jointly organized by Eurostat and European Statistical System. She is elected president of the Italian Statistical Society and the president-elect of the International Association of Survey Statisticians. Her main research interests include small area estimation, analysis of survey data, and official statistics. Caterina Giusti is Associate Professor of Statistics at the Department of Economics and Management of the University of Pisa and member of the Tuscany Inter-University Center Camillo da Gum. Her main research interests include small area estimation, analysis of survey data, poverty mapping, multidimensional indicators of poverty and living conditions. She was and is currently involved in the research and coordination activity of several projects funded by the European Commission, and she is currently involved in the coordination activity of the European Master in Official Statistics. Today, they will present about small area estimation for mapping local indicators. And Monica, the floor now is yours until the first question break.
Okay, good afternoon. Can you hear me? Yes, I think yes.
Yes, so, I can hear you.
Many thanks. So why we are here? First of all, I must admit that this topic, small area estimation for mapping local indicators, is our beloved themes of research. I am here to represent the results obtained by a group of research that is at the University of Pisa, Camillo da Gum Center. But after saying that, I add that the main motivation is that we need for local information. So local information that is local, meaningful flash data and indicators on poverty and vulnerabilities, obviously, but also many other phenomena as the Sustainable Development Goals are suggesting us. So all this information must be useful and understandable to policy making. And in addition, the decision on what data and how collect them is not neutral, but it is a map of reality that define and is useful given the goal of the policymaker. So sometimes it's important to have a signal and not an error-free estimate. And this is why small area estimation is important. I have cited here two projects we are involved in. The first Maxwell and the other is Ingrid too. And these two projects are dedicated to a wider topic, not only small area estimation, but in both of them, small area estimation has an important role. So the need for information. You know that when you are setting a decision-making project, you need, first of all, to individuate priorities, then to design the policies and actions, and then to evaluate the results. But in every one of these three steps, you need data. First of all, need for data because you need figures and maps, results of analysis, indicators, and then you need also models to simulate scenarios and to specify also econometric models and statistical models. And also methods to evaluate the results ex ante, in itinere, or for ex post evaluation. But every one of these three steps is data hungry. And you need to produce adequate data to support the decision-making process. And as you can see immediately, the collection and analysis of existing data is important, but it is important also the production of new data and indicators. And in this part, the small area estimation plays an important role. Also because nowadays we need to integrate data coming from several sources, also from big data sources or new surveys as well. And so you need something that provides you timely estimates, integrating all the information you have. But not only at the initial part you need data. You need data also when you build what-if scenarios for microsimulations, for instance. And also in this context, having information at a more detailed geographical level or for domains of interest becomes important. Then at the final step, the step of evaluation, again, you need to have new data at a local level in order to judge if the actions you took had an effect. And everything must be coherent, obviously, from the first to the third step. And nowadays that we are under the Sustainable Development Goals monitoring process, and today, when poverty is an issue, it is important to have data. And as a matter of fact, we have data produced by Eurostat. Eurostat collects data from an harmonized set of current surveys. You obviously know them: the European Survey on Income and Living Conditions, the Household Budget Survey, the Labour Force Survey. And these are conducted every year in a harmonized way in each member state. And you can have also for Labour Force Survey every trimester fresh data in member states. Nevertheless, there is an additional issue, another ingredient that is important. So we need data, we have seen why, but we need local data. What does local mean? It is obvious that we need to measure poverty, just to make an example of local indicator, where it matters, that is, in the places where people live. And then local is an attribute not defined once forever. And this is another issue, because this moving definition is producing some difficulties in the data production flow. There is a classification of territorial units, I would say a traditional official classification of territorial units for statistics. They are called NUTS, The names derive from French. I don't want to pronounce it in French because I don't speak this language. But in any case, they are subdivisions of countries for statistical purposes. In addition, the 3 levels of NUTS defined, there are other 2 levels of local administrative units, and these are below the NUTS. But not all countries have every level of divisions, and this is depending on their size. Just to make an example, there is an extreme case, Luxembourg, which has only 1 local administrative unit, and the 3 NUTS divisions each correspond to the entire country itself. So the situation is different in the member states. NUTS 1 in Italy are the regions, and they are groups of regions, sorry, not regions, groups of regions, and there are 5. In Germany, we have 16 states. And here you have a map just to make you aware of what we are talking. Then NUTS 2. NUTS 2 are the regions in Italy, 21. In Germany, the government regions, and we go at a more local level in such a way. NUTS 3, provinces in Italy, districts in Germany, and you can see that the number of them can vary from one member state to the other. But now, coming to a smaller geographical detail, we can say that it is true, Eurostat publishes estimates at NUTS 1 and NUTS 2 level, coming from the surveys I have just mentioned. And these estimates are called direct estimates because they are coming directly from a sample survey, and they are design-based estimate from sample data. But sometimes the domain of interest is different than the NUTS level we have just mentioned, and we call it small area. Obviously, the adjective small qualify at first the dimension of its area in terms of its extension, but small areas can be also groups of population identified not only by geography. But in any case, for small area, we are indicating a domain of interest for which the sample size is not adequate to produce reliable, accurate, I would say, direct estimates. And generally in EU, this is lower than NUTS 2 level. There is another classification, other geographical classification that is important today, that is called the GURBA. This is the degree of urbanization of local administrative units 2, and can classify them in 3 categories: cities, towns and suburbs, and rural areas. This is in conjunction with the population density in those areas, and it is a very important classification because it allows us to go into a deeper analysis of what is going on where people live. Now, coming back to the objective, reliable and accurate. What's accuracy? Accuracy is an important ingredient of our final recipe. I have listed here many ingredients: decision-making, survey data, data integration, uncertainty of the results, uncertainty of the estimate. And accuracy is an ingredient, is an important one, because it is the degree to which the information correctly describes the phenomena it was designed to measure. Obviously, given that the measurement is valid, and this is out of this talk, the problem of validity. But generally, accuracy is described in terms of error in statistical estimates, and it's decomposed into bias, that is the systematic part of error, and variance, the random error component. Clearly, this accuracy is, I would say, a phase of uncertainty of the estimates we are producing. And small area estimates are new statistics, and they are affected by a degree of uncertainty. Like direct estimates, they both are affected by a degree of uncertainty. And the issue is how to control this uncertainty, how to improve the accuracy. There are examples. We are not the first ones. I like here to cite the work by Kenneth Simler, Pinpointing Poverty in Europe, New Evidence for Policy Making. That is a report based on small area estimation. And so, after I have just listed all the ingredients, I'm asking you if you have questions on what I have just told.
Yeah, if you have any question regarding the first part of this presentation, please use the chat. However, there is a comment about the GURBA did not have any classification for islands, so there is no measurement data, only you can use survey.
Yes, that's an important comment, and maybe we should, not we, but Eurostat should extend it in order to cover also islands. This is my opinion about that. Okay, Croatia, yeah, that's an issue. Should I go on?
You can go on, and we will have another break in a few minutes. Okay.
10 minutes, okay. Okay, now, we evoked estimation, scope and purpose of estimation. What is estimation? I could say that's a process that approximates unknown population parameters using only the part of the population that you have sampled, that is included in the sample. There are many examples of parameters. They can be simple descriptive statistics, ratios and percentiles, or more complex statistics like poverty indicators, or also analytical statistics like regression coefficients. So we have survey data and we want to estimate, to provide values for parameters referred to the population. We indirect estimate. Proper estimation conforms to the sample design, the sampling design. So sampling weights are incorporated in the estimation process through stratification, clustering, and multi-phase or multi-stage information. But now, not only this is included in the estimation process, also what we call auxiliary variables, auxiliary data. So data that we have from other sources to integrate in our estimation process to improve the reliability of the estimates. Obviously, we have to evaluate the use of auxiliary data, but nowadays there are so many that it is important to use estimation methods able to integrate them and to take advantage of them. Whenever they come from traditional data sources like recent census counts or administrative data files, but also coming from big data sources. Now, there are many suggestions. I quote here a suggestion coming from Statistics Canada, that is an official agency operating in Canada. And they suggest to use all the information you can have and also to take advantage of the sampling design, especially of the sample allocation stage, in order to increase the number of observations you have in the domain of your interest, in order to avoid the use of modeling to obtain new data, new statistics. But if you cannot do like this, they are the first to suggest small area estimators. And they say, borrow strength. And this is another important ingredient in our talk. That is, the methods we are going to present here are borrowing strength from the values you have from related areas or domain, and they are borrowing strength in space and time, using also spatial and temporal dimensions in order to reinforce the accuracy of the final estimate. The general goal is to control accuracy, that is, to minimize the mean square error of the resulting estimates. So you see here many other quotings, but you can have at the end of this talk a list of references you can use. Now, what's small area estimation? Now we are ready to say that's a methodology for producing estimates for more detailed level of geography that can be reliably obtained from survey direct estimates. It can be conceptually similar to this, to other disaggregated values that you can have at finer classification levels of industry, income group, or labor force status. They are very similar to domain estimates. The difference is how they are obtained. They are obtained combining survey data, so surveys are here to stay, in few words, and auxiliary data sources such as administrative data, big data sources, census recent counts, and so on. But at the end of the day, small area estimation results are new statistics. And when I say new, I say that they weren't, they didn't exist before the process of small area estimation. And they are not otherwise available from survey or administrative data sources. Obviously, watch out. Also, some administrative data can be used to produce statistics for small areas, okay? Not only surveys, and also big data sources. But the problem is that we need to comment on the accuracy we can have using these sources alone. And so small area estimation is a way also to quantify uncertainty of the estimates. And this is another important issue, according to me. Now, small area estimation is a set of analytical methods and may have a crucial role for producing official statistics, and as it is easily understandable from what I have said. And these analytical methods are not always well accepted in the official statistical world. But there are prominent researchers like Graham Carlton that recently stated that the opposition to using models in official statistics has been overcome by the growing demand for small area estimation. And this is important, this is true, but from the other side, we need to work to ensure that methods and assumptions are described for user, because the validity of the modeled estimates are to be assessed. Now, summing up, another suggestion coming from the other part of the world, the Australian Bureau of Statistics. This is a good paragraph, according to me, because put together words like availability of auxiliary data, relationship between this data and the variable of interest at the small area level. So this borrowing strength is again recalled, and it is clarified that the borrowing strength process is reinforcing coming from auxiliary data to increase the accuracy of the estimates. So small area models is not small area modeling is not a joke. It's something that requires statistical skills and can range from simple models to more complex models. Literature is full of proposals, and there are very important authors like John Rao and Isabel Molina collecting in books all these efforts. And in scientific journals, you can have hundreds of proposals under the small area estimation label. But in any case, it requires time, effort, technical skills, and available data. And above all, it requires also a range of quantitative and qualitative diagnostics in order to choose the best model for given data. Now, this is a tentative classification of the small area methods. There is a tree. This tree has two branches. The first one goes towards direct estimators. They can be used to have oversampling, maybe. They can be used to have reliable estimates for the domains of interest. But the heavier part is dedicated to the small area estimation, not based only on direct estimates. And here you can have a classification of this borrowing strength in pink, you can see here. You can have model-assisted small area estimation or model-based models, model-based inference for small area models. And this is an important distinction, because when we go from this branch to the other, we have a different way of doing inference. Here, inference is based on the design properties. On the other side, inference is based instead on the specification of the model and can be assisted also by the design. But in many cases, when you use the model, your inference is based on the model itself and on its properties. The main subdivision here is on unit level models and area level models methods. And this is a distinction that we do on the basis of the auxiliary information available. That's why in the examples that Caterina is going to present after my first part of the talk, we are differentiating the usage of the models according to the availability of the information. EBLAP, empirical best linear unbiased predictor, is present also, is present both as a unit level or area level small area estimates, and there are also many other proposals that you can read in the literature, also taking advantage of the spatial information and of the temporal dimension that you can have in this auxiliary information set. Now, rashly, okay, I'm rushing on the quality of small area estimates. First of all, timeliness. They are, I would say, flash estimate. They should be flash estimate produced immediately after the survey data are collected, and very soon. So they can be defined as timely and cost-effective flash estimates. They are also accessible in the sense that they are offered through maps. Poverty mapping is an example, a leading example in this. Obviously, this usage of the mapping of the maps call from an expertise also in reading cartogram and in reading cartography, so can be questionable if it is an easy medium of accessibility, but is the more common. And also interpretability. Interpretability is another issue referring to the quality of small area estimation. And that in this sense, we need also supplementary information and metadata to accompany the estimates, and they are necessary to interpret and utilize appropriately the small area estimation. Coherence with other data available at a higher geographical detail is important. And for this, there are many proposals focusing on calibration, benchmarking, and harmonization of the small area estimates with other estimates available at higher geographical level. Now, we can say that to have a successful small area study, we need to have a good interaction between commitment and client, let me call them like this, and also we need ability to work closely with users. The variable of interest, and this is very important for the Sustainable Development Goals monitoring, should be reasonably common population characteristics. That is, rare phenomena are difficult to estimate with the small area methods. And obviously, also the population size of the small area is relevant. It is important that small areas contain some sample, even if we can produce predictors for out-of-sample areas, so areas with no sample inside. And also the significant relationship between the auxiliary variable and the variable of interest is crucial. And referring to the choice of model for psi, for small area estimation, it must be plausible, okay, in the light of previous studies and accepted wisdom. The fitting to the observed data is important, and also the accuracy of the small area estimates predicted from the model is important. So we need diagnostics, and Caterina will show you some example of it. The first one is to have a bias test comparing the small area predictions and with direct estimates where they are present. Then the model assumptions must be tested to have a good fit. We need to benchmark to published state or national estimates. Involving of subject matter experts on the phenomena is important to have a judgment of the spread of estimates across small areas. And finally, last but not least, the relative root mean square error, that is analogous to sampling errors calculated for survey estimates. In few words, you maybe, I'm sure that you know that when we are using survey data, we have sampling error and non-sampling error components. And we use the survey data and the auxiliary data in order to produce measurements of the both components of error. But adding small area models means that you have an additional component that is due to the specification of the model. And so we need to reason in terms of total error. And this is obviously useful to judge the quality of the small area estimators and to take full advantage of user decision for the user to do a good decision-making process. We need to document the results underlying all the steps I have just mentioned. This is very important, otherwise the small area estimates, according to me, should not be published, even if they are more accurate than the direct estimates. And this documentation includes the problem, the procedure, the quality issues, and then a summary of key issues and recommendations. I would like to tell you that obviously research is not stopping on the quality diagnostics. And there are other quality issues. They are more or less a sort of frontier of what is going on the expansion of this small area estimation literature. There is the issue of sensitivity of the spatial model, the problem of modifiable area unit problem, the shrinkage effect that we have when we examine the small area estimate distribution across areas. There is the issue of robustness against outliers, the treatment of zero values in the study variable. There are many open issues on which we are doing, and every researcher can do research. So, concluding, we need a careful assessment of small area estimation. We need to communicate with stakeholders, with decision makers, with policy makers. We need also to put value on the auxiliary variables, to study them very well, and then finally to document the results, focusing on models and on the quality of the outputs. Okay, many thanks.
Okay.
Are there questions?
Yeah, before giving the floor to Caterina, there are some questions. The first question is, where is possible to see your survey and what are you using on it? For example, some people have seasonal job and when it's convenient to take survey during seasonal jobs in tourism or after, or take both. I think that the question are two. The first question is where is possible to find the survey, and the second question is a sort of example. I think she's asking your opinion about it.
Okay, the first survey, to see your survey, what are you using in it? So this is a question on a survey on tourism or on labor force. I think that maybe it's a question on the labor force survey. Okay. And the usage of it. So this labor force survey is produced by National Statistical Institutes and harmonized by Eurostat according to an harmonization set of rules by Eurostat. And it depends what you want to have. If you need microdata, I think that in Italy you can access microdata with a procedure that is called Adele Laboratory, Adele Lab, and you should have a research project to access these data. And then after that you can have all the waves of the labor force survey. The fact of having seasonal jobs, and the question is when should we do a cross-section or longitudinal survey in order to have an idea of where people is working. And this is another issue can be also faced using the definition of convenient domains. These domains can be temporal domains or can be also geographical domains, depending on where people working during the seasons are located, and depending also on the sector of activities of these persons. And then there is another question.
There is another question, and is why in the diagram, I think the diagram at slide 21, direct estimation is under SAE. I think that SEM is SAE. As far as I know, direct estimator is designed based on sample survey. And same question for Greg. 21.
So your project, okay. Okay, so direct estimators are put under the small area estimators. This is because of the suggestion by Statistics Canada. They said that whenever it's possible to produce estimates at local level, use the survey data, trying to manage to oversample in the so-called small areas, and using all the attributes of the sample design you can use in order to improve the accuracy of these estimates. Basically, you can work with Horvitz-Thompson-like estimators, including auxiliary information to transform them in regression estimator or generalized regression estimators like Greg. Greg can be seen also as a method that is classified under the model-assisted approach. This is because inside the generalized regression estimator, as the name itself is saying, you have the assumption of linear regression between y variable, your study variable, and the auxiliary information. And there is the possibility of making inference, evaluating the properties of this greg, both under the design, like direct estimators, and under the model. And this is why you can find it on the right side of the scheme.
Okay, and then there is a comment about statistical data I could not use as relevant. For example, in some area there is no unemployment problem because there are no people.
This is a very interesting question, because this is relating to the zero values that we can have in some areas. Zero observation can have two meaning. First of all, you are in and out of sample area, that is, you have no observations because you are out of the sample. But it can also be that you are in the sample, but the phenomenon is not present in the area. And this can cause additional complexity in the modeling exercise. Maybe you have to combine two different models. Poisson modeling, maybe, and logistic regression in order to put in the small area estimation model both these possibilities. No persons, no sample, no phenomenon, and no sample. Now,
we have a last question before giving the floor to Caterina, and then maybe we can discuss deeper in the end of the presentation. But the question is, I think you haven't mentioned the spatio-temporal approach. Are there some spatio-temporal EBLAP estimator for that?
Okay, so I have said that borrowing strength can be borrowing strength in space and time, both together. Yes, for sure, there are many contributions trying to formalize a spatial EBLAP, adding also the temporal dimension, for sure. Yes, I had not the ambition of making a full review of everything in the first part, but only to mention some ingredients in order to understand the examples that we are producing. Obviously, small area estimation is a so wide topic in literature that we should have more than one webinar to go in depth. This is just to make to give you the flavor of the issue. And so, sorry, the floor is to Caterina for the second part.
Yeah.
Thank you, Guy, and thank you, Monica, to ask me to share with you this presentation. So yeah, I will ask just to show you some example, which are actually some application, very simple application that we produced in the last year, with the aim of show you how a small area estimation model works, both at the unit and the area level. So when we need to produce what can be called new statistics at the unit level, what we have usually are some survey data. In this survey data, we have both the target variability that we indicate with Y and the auxiliary variable X. Usually we have more than one auxiliary variable. Then we also have some census or administrative data where we have the same X variable or X variables, but we don't have the target variability. So basically the idea of area level small area estimation models, and I will refer maybe to the EBLAP, is to use the survey data to estimate a model that links the Y to the X, and then use the estimated model parameters to estimate the Y values for all the population, since the census and administrative data should cover all the population. So basically, I also have a scheme on this here. So the idea, you have the sample data with the target and auxiliary variable. On this, we specify the model. With the EBLA is the classical linear mixed model where we have area and unit effects, okay? And then, having fixed the model, we can use the estimated parameter, like the betas, apply this to the X variable referring to all the population, and then in this way, we can predict the Y values for all the population units. This will result in area estimates, for example, the mean or the total of the Y values in the areas of interest will have a reduced variability with respect to the direct estimate of the same variable. And I'm going to show you here an applications that we did to estimate the mean equivalized income of the household living in the 10 provinces of the Tuscany region in Italy. So we used data from the EUSILC survey 2016, where we have the equivalized income available for each of the sample households, and we have also a list of potential auxiliary variables. And then the same X, of course, we restrict our attention to the same X that were also available from the census of the population 2011. Of course, you can see we had a time gap between the survey and the population census, but this, of course, is the problem of the population census, which now even disappeared. This was the last full population census 2011. So the aim was to estimate the mean of the household equivalized income in each of the 10 areas, in each of the 10 provinces, by using an EBLAP model. In this application, the municipality of Florence was considered as a standalone area since the sample size was large enough in that area. And this is an example of the X variables that we use. So the important is that these variables are in common from the EUSILC and the population census. So we could use them in our unit level model. So you see there are general characteristics like the household size, the ownership of the house by the household, and then the age of the head of the household, the year of education of the head of the households, and the working position of the head of the household. So the unit here are just the households. Okay, so the aim was to obtain estimates of the mean household equivalized income in the provinces with a reduced variability. So here you can see the results, the point estimates, mean household equivalized income. It is represented on the map of Tuscany. On the left, you have the design-based estimates, where this means the direct estimates. On the right, you have the EBLAP estimates. So you can see that by the colors, so the mean equivalized income is represented in classes. We see that something changes from the direct to the model-based estimates. But what I think is even more important, which cannot directly be represented on the bars, is how using the model helps in getting more accuracy for the estimates. So here you see basically some interval estimates. So you have the provinces on the x-axis, and you have the equivalized income on the y-axis. So the dots represent the point estimates for each of the provinces. And you see you have two. You have in black and in red. So the black are the direct estimates, and the bars represent the corresponding errors, I mean the full interval, while the red are the model-based estimates with the corresponding error. So what you can see, of course, is that in some provinces we have different estimates that was the same represented in the map. And what we can notice here is that we were able to reduce the error. So you can see, especially in some provinces where we had a reduced sample size, using the model, we were able to highly restrict the error, the bar, the interval estimates, which was indeed our aim. Of course, we can test the assumption of the model. I will not show this into detail because I want to show you an example of area level model. You can find more details in the papers, in our references that you have listed at the end of the slides. What instead if we want to apply, or we need to apply, a smaller estimation model at the area level? So this is the case when you are, what you have are direct estimates at the area level, which are usually available again from a survey, but these direct estimates, for example, again of the mean household income, has a higher variability. But in this case, you can use as covariate in your model area level information, area level covariates. So you are not, you have no variability or unit level information. So in these cases, you use an area level model, and I will show you also the formula in 1 minute. So the idea of area level model, and again here I will just refer to the standard EBLAP, the Fayet-Elliott model, but more advanced modeling also exists, as Monica showed you in the scheme, and we know that the scheme is not complete. But the main idea of area level model is to link the area direct estimates to area level covariates, with the aim of reducing again, the variability of the direct estimates. What we expect in this case is to have a high correlation of the final estimates, but a reduction in variability. And okay, these are the formulas. Of course, we will not go into details. So again, we have a parameter of interest, high, the index represents the areas, so the parameter can be an area total or an area mean, and we model it on a covariates and on some area level effects, the U variable. But actually then, what we model is this, so the hat theta represents the direct estimates of the area, and we consider, you see on at the end of the slide, you see we link this with some covariates, and we estimate the beta parameter, and then we have the area effects, and we also have the design errors. The high represent the design error, the sampling errors. So this is the classical Fay-Elliott model. And again, I show you an application to measuring the household equivalized income. In this case, the target areas are the 57 local labor system of the Tuscany region, Italy. Again, the data on household income comes from the EU-SILK survey. And well, about local labor system, basically are very similar to what are called travel to work areas in other countries. So they are areas that are supposed to represent single labor markets. And these are intermediate between the LAU 1 and 2 levels in the classification that also Monica already presented. In this case, and this is very important, we also have 24 out of sample areas. So for this area, we did not have the direct estimates from the EU-SILK survey. And this is important because we can also use the model, the area level model, to predict the values for this area, the values of the target parameter of the mean household income. So in this application, actually, we use, in any case, the covariates coming from the population census, because we were using the EU-SILK referring exactly to the same here of the population census. But usually, remember what is important, in area level model, we can use any kind of sources for the covariates. But this, under the standard Fay-Elliott model, these covariates should be known without error. If you plan to use covariates coming from a survey or from another sources where some error is present, you should use some modification, some more advanced formalization of the Fay-Elliott model. While the standard Fay-Elliott model, the covariates are supposed to be known without error. So you can see here the list of the covariates. So some proportion about the level of education, the presence of non-Italians made in the population of these areas, so area level covariates. And we just estimated the R square using a standard linear regression, and we see that the covariates had higher predictive power for our Y variable. That's why we decided to use it. And actually, in this case, we use a spatial Fay-Elliott model because we tested for the correlation of our estimates, and even considering even conditioning on the covariates, there was still some spatial correlation. So that's why we decided to use a spatial model here. Again, this is a map where we can represent our new data, the new statistics that we produce with the model. You see again Tuscany, and now we see more areas with respect to the provinces because they are the 57 local labor system, and we also are able to predict. So you don't see any empty areas. So all are colored because we use also the model to predict the out of sample areas. And again, some ideas, some diagnostics on the model. So on the left graph, I'm just checking the correlation between the direct estimates and the spatial Fay-Elliott estimates. The correlation you see is high. We have some for higher values, something maybe is not so highly correlated, but this is something that can be checked, and we can also expect when working with, of course, true data. While with the graph on the right, again, I'm checking if with the model, we were able to reduce the variability. So on the X, you have represented the sample size, increasing sample size for the areas, while on the Y-axis here, you have the root mean square error. And with the empty dots, we see the variability, the root mean square error of the direct estimates with the black dots, you see the model-based root mean square error. So the idea is that you can easily see with the graphical representation that especially, I mean, for the areas with the reduced sample size, so the first dots on the left in the graphic, you see how much we were able to downgrade the root mean square error. So the empty dots are very, very high, while with the black dots we were able, means that we are able to reduce the variability, while of course the difference decreases as the sample size increases. And this is something that, again, we expect. Of course, also in this case, as I briefly show, we have some assumption of model distribution, of normal distribution under the model. Again, it's a classical linear mixed model, so we should also test if these assumptions are satisfied. But I will not again focus on this because I want to show you very briefly some new application that we are developing, some more, I would say, also advanced application. So this is a very recent one. We were just trying to get some local estimates of educational poverty. Educational poverty is, can be considered as deprivation of ability to learn, experiment, and develop and freely flourish skills, talents, and aspiration. And we decided to measure this very interesting, I will say, in some kind new phenomenon that is now considered as very important in many, I would say also political agenda. We decided to measure it as it defined currently by the Italian National Statistical Institute, ISTAT. For ISTAT, educational poverty is a multidimensional phenomenon that can be measured as a mixture of problems related to material, relational, and cultural environment kind, which can limit the abilities of people to live in a complex society. And especially, ISTA decided for the moment to target this index to the population aged 15 to 29. So this is not an index just focusing on education, especially of kids. It's something more general. This is educational poverty is think about a more macro level phenomenon reflecting the general difficult experience by the people. And what is important, and that motivated our work, is that we believe that it's important to estimate this phenomenon at the local level, because of course this can help the policymakers in the decision making, as Monica just was presenting. At the moment, indeed, ISTAT just estimate this index for the NUTS at the NUTS 1 level, so just 4 areas in all Italy, again, as Monica already presented. But we decided to try to estimate this at the more local level. And we decided indeed to investigate, to define our target areas as the cross-classification by the NUTS 2 level, the regions, and the degrees of urbanization as measured by the De Curva classification. Why? Because in many studies, it was observed that poverty can be different for different degrees of urbanization levels. And so we wanted to investigate if this can also supposed to be true for educational poverty. So at the end, in this study, we have 49 areas, 49 small areas, given by this cross-classification, 20 regions by 3 De Curva levels, 59 because in Trentino Alto Adige regions, we have no cities, no densely populated areas. So in the ISTAT index about educational poverty, 4 dimensions are considered. So it's a multidimensional index. We have the participation dimension representing the participation of the youngsters, these people aged 15 to 29, we call them youngsters, their participation to their social life. Resilience represents the development of an attitude of trusting oneself or one's ability. Standard of living is a dimension representing the ability to lead an inclusive, healthy, and safe life. And friends' skill, the ability to weave relationship with others and achieve those skills needed to success in a fast-paced world. So to measure the dimension, we use indicators coming from the Aspects of Everyday Life survey. And in this survey, if we directly measure the indicator that I will show you in some seconds, just using the survey data, we get a very large variability. So these indicators measured in the 59 areas that I was referring to need the use of small area estimation techniques. So here you have in this scheme represented just by the name the indicators that are used to measure each of the 4 dimensions. So the idea is that we cannot trust the direct estimates of the indicators as measured from the aspect of the data survey for each of the 59 areas of interest, because they have a high variability. Of course, the cross-classification, the GURBA by region, is not a planned domain for this survey. So what we did, we just used a different area level small area estimation model to get a more precise estimate, to reduce the variability of each of these indicators. And then we did this two-step aggregation to get the final PI, so the final estimate referring to each, the final educational poverty measure referring to each of the target areas. And these are the results, just to show you what we are able to produce and why we wanted it, to show you the aim that we had and what we obtained. So this is the map of Italy. The black boundaries represent the regions, but inside the regions, you see we have many areas, because we have the degree of urbanization that basically cuts into each of the regions. So in general, you see the white represent the mean level of educational poverty. The final aggregation of the index was done by the Mazzotta-Pareto methodology to aggregate in many dimensions in a single composite indicator. This is the methodology that is used by ISTAT for aggregating the dimensions. So in general, white is the mean level of educational poverty. The green represents a lower level of educational poverty. The red, a higher level of educational poverty. So we can see just by looking at the map, the north-south divide that maybe you also know characterized historically from many social economic perspective the Italian territory. And indeed, on the right, you can see Trentino Alto Adige. You see everything is green in Trentino Alto Adige. So it means that even considering the degree of urbanization, we have no differences. So I will say the educational poverty doesn't see an issue there. But if we consider other regions, and I will just show you Lombardia, a region in the north on the left, and Sicilia, an island on the right, you can see that indeed in some regions we have some diverse areas. So Lombardia, you see the green is the Milan areas. That means low levels of educational poverty. But in the surrounding of Milan, in the suburb areas, we have the orange, which means a higher level of educational poverty. And look at Sicilia. There you have both green and red areas. So a very diverse level of educational poverty, considering the degree of urbanization and the further classification inside the region. So that's, we think, is very important, because it shows that we have a variability inside the regions. So even just focusing on the regions, the NUTS2 level as target areas, we lose these important dimensions. And just a very brief diagnostic, this show you, in this table, we show you the coefficient of variation, so the standard deviation over the mean as a measure of variability of the direct and Fayet-Ariot estimates. So for each indicator, you can see how we were able to reduce the variability. Basically, here we consider three classes for the coefficient of variation values. The first class means that we have the number of areas for which we had the coefficient of variation below the 16.6%. And this means, according to Statistics Canada, that these estimates can be trusted, can be published. While in the class 16.6 to 33.3%, we have other areas. So in these cases, the idea is that we should be cautious in commenting, in publishing the results, while the last class of areas and indicators means that we have coefficient of variation over 33.3%, and these are considered usually unpublished estimates. And what you can see in the table is that with the Fayet-Ariot estimates, we are able to highly reduce the number of areas with coefficient of variation in the middle and highest class of coefficient of variation values. So that's a good result. You can also see that we have no all zeros in the last columns in the Fayet-Ariot part. So something can be further improved, especially modeling some of the indicators. And of course, it is something that we will try to do in next step of this work. So we have, I think, finished the time. Just a couple of slides to mention that using area level models give us also the possibility to use new data sources like the famous big data in small area estimation. And this is something that we did in some application. Basically, we decided to use some new data, some data measure using big data as covariates in our area level models. So just to give an idea, in these two maps, you see representing our target variable, that in this case was the share of food consumption in Italian provinces. So the percentage of the total consumption of the household dedicated to food that can be considered as like a proxy or something that is linked to poverty. So usually the higher is the share of the consumption that the household dedicated to food, the higher tend to be the poverty of the household. We use this measure because we were using household budget survey data. So we were not just measuring directly poverty in this case from the EU-SILC survey. And on the right, you can see this blue map. In this blue map, we were just using the high happy indicator. This was a measure based on Twitter data. Okay, so some researchers just measured the percentage of happy tweets over the total of tweets in each of the provinces. And what we observed was this nice, I would say, high correlation. So you see in the two maps, basically the darker colors represent, I would say, a better situation. Okay, so on the left, the higher the color, the less is the share of food consumption. On the right, the higher the column, the happiest are the provinces. So based on this correlation, we decided to use this happy indicator as the covariate in our model, and this helps in reducing the variability. Okay, so of course, important to say that the aim is not to interpret then the beta parameter. Okay, so our aim is to find some correlation and show that this covariate is able to help us in reducing the variability of the direct estimates. And in the same flavor, we did another application. Again, at the end, you find the references to the papers if you are curious to have more details, or of course you can ask me in the chat in a second. I will finish. So in this application, we used again, we model the link between the headcount ratio, so the share of poor households in the provinces of the Tuscany region, and we correlated it. You see here represented the negative correlation with the measure of mobility based on GPS data. So together from our colleagues from the computer science department of the University of Pisa, we have this information that help us to understand how people living in this area moves. This was based on GPS tracks of their cars. Of course, it was just based on samples of observation, but in any case, just the idea is that the lower is the people move in the provinces, the higher seems to be the poverty. So this is again just, we know that it is not, of course, any causal effect, but there is maybe both are proxy on something, and so it makes sense to use this as a covariate in the model. Of course, and then I close. Remember, as I said, that everything that is X variable that goes into a Fayet model should be measured without error. So when you use big data, the question is, what kind of data are these? Are population data? Are a sample from a larger set of data? So in any case, if you think of using an X variable that is measured with some kinds of error, in big data, of course, this is a problem in itself, I think, but remember that we have extensions like the E-bar version of the Fayet model, where you can use, we can introduce also X variable that have an error themselves. So coming from a survey or big data where the problem is how to measure the variability of this big data. And of course, these are very, I would say, challenging questions. And what we can do is just to try to work on this. And all our works, and we continue to do so, were developed in the last years and in the future under these three main projects. So you can find more references to our works looking at the website of these projects. And in any case, we also included here some list of references. So you can find them in the PDF version on the EMOS 2020 website. for your references. Thank you.
Many thanks, Caterina and Monica. If you have any question for Caterina or Monica as a final discussion, question and comments, please. Okay, we have a question. The Sicily EP map seems to be very difficult to understand. The green area covers the poorest and the less developed part of Sicily. I would expect the opposite. Is there an explanation?
Yeah, of course, it depends on how the educational poverty index is defined. Okay, so of course, Monica and indeed also Gaia work on this with me, so they can, of course, add. So in this case, poverty, I mean, monetary poverty doesn't play a direct role. So we are just more focusing also on the social participation of the individuals and so on. So that's why maybe we can find some, I would say, unexpected results. Okay, so I don't remember exactly which dimension was more important in Sicily, but I think, for example, that in some areas the social participation was just putting the overall index down. Okay, so of course, to better appreciate this, you have the reference for our publication. So I think if you look at it, how educational poverty is defined by this index, you will better understand why we obtained this result. Okay, so of course, if we change the definition, and of course, finding new dimensions of educational poverty is something that we are going to consider in the future, maybe we will find different results in Sicily or also in other parts of Italy. So I think that the results highly depends on the specific definition that we used.
And then we have a second question. When there is a significant difference between direct estimations and EBLAP, how can you be sure that EBLAP is closer to the truth? He is referring to your example, okay? And the same goes for overestimating error intervals.
Yeah, of course, we cannot be sure. What we usually do, we test also for different models. We try to test the robustness of the model because, of course, we are not sure that the model is always true. So what we have to do just to maybe do some sensitivity analysis to test this. So maybe change the axis, add something or remove something of the axis to check if something changes. Then, of course, usually what we did in any case, I think that's important since we are doing research, especially in papers, but also in reports, we just report everything, the correlation, the graphical representation. And so this also can help, I think, in the discussion of the results.
Okay.
Yeah, Monica, please.
Okay, may I add?
Yeah.
Okay, on this last issue, no one here is a magician, and this is the truth. I would say that we all need to educate ourselves to a procedure of controlling uncertainty that is, I would say, shared by the scientific world. This is the only thing that we can do. So, in the survey methodologists and statisticians community, mean square error is considered that as a measure of accuracy. So at the best of our knowledge, what we can do is to reduce it. When this is not obtained, as you noticed, how can we compare the EBLAP and the direct estimator if there is this problem with confidence intervals in case of I would say underestimation or overestimation. The only thing that we can do is trying to, as Caterina said, trying to change the model. And in any case, be careful of the diagnostics results. This must be done always. Otherwise, we are simply chatting about uncertainty of the results without having a guideline to orienteering and to find out a direction and then to trust the final results. This is always true, and I would say that is even more true nowadays when we are facing so difficult times where statistical data are so common and commented and I would say shared, and in some cases so so tortured that they are confessing everything. Okay, so many thanks for the question, because these questions on how to communicate uncertainties is very, very important.
Yeah, and there is a comment, Joao Lopez, I hope I pronounce it in the right way. He suggests that the first step should be to use synthetic data to understand how the model is working.
Yes, for sure. Synthetic data, you mean simulated data. So simulating scenarios obviously is the first things to do, for sure. Many thanks.
And there are any other questions, or we can close this webinar. So thank you, Monica and Caterina, for this insightful lecture, and many thanks to all our participants who joined us today from many different places. You can already download the presentation from the EMOS 2020 events website, where the recording of the webinar will be available as soon as possible. And on the same website, the recordings of the first 8 webinars of the program are already available. In the meantime, I kindly ask you to check the inbox of the email account you use for registering to the webinar, as you have already received the link to a short survey about today's webinars. We'd really appreciate your feedback and further improve our webinar. The next webinar is scheduled on Tuesday, the 12th of May, when Edith Deleuve and Anne Elvet from Utrecht University will be presenting on mixed mode survey. Please note that due to the current emergency situation, the webinar on Beyond CDP, what have we accomplished so far, originally scheduled on next Tuesday, has been rescheduled to Thursday, 18th of June at 4:00 p.m. Registration to the webinar will be valid for the new date, so you don't need to register again. And thank you for now, and have a nice evening. Bye.
Thank you. Bye-bye. Thank you for everything, Gaia. Bye.
Bye.